Hi everyone, so we're going to be starting something new. So plate tectonics, a lot of you might have some familiarities with what plate tectonics are. We're going to talk about a little bit how it affects our ocean and how those things move and change the Earth. So continental drift is our first topic here. So in the 1600s, we see our first accurate world map. And if you take a look at this map here below, you can see that it doesn't exactly look like what we see today. So if we take a look, what we would see would be Africa here is connected to Asia, unlike what we expect to see, where Africa is kind of drifting by itself. Again here, the Americas are again looking very different from what we normally expect here. So it's observed that these continents are fitting together like puzzle pieces, which is kind of peculiar. And the reason for this is those tectonic plates. So about 200 million years ago, all of our continents were connected. So if we take a look at all of these different continents that we know, Eurasia is the combination of Europe and Asia. We can see North America here, South America, Africa, Antarctica, India, and Australia, all in places where you wouldn't expect to see all of these continents. And these are called Pangea, that supercontinent. And the reason that we know that these things happened was because of our fossil records. So we have found the same fossils from the same animals on different continents. And the only good explanation for that is being able to see that all of those continents were connected at some point. So a specific fern that was found in South America, Africa, Australia, India, and Antarctica. The reason that this was kind of impossible was because the seeds were too heavy for the wind to carry them and too fragile to cross an ocean. So finding this fern on all of those different continents that are nowhere near each other is a really big hint to Pangea being possible at some point in time. The same thing has happened for different animals as well. So we've found animals of the same species, same size, everything like that on different continents. And these animals were not animals that could swim or do anything like that. So it's the only explanation is Pangea at this point. So if we take a look at some of these examples, we can see that this fossil here of our Cynogenus from our Jurassic period has also been found in Africa as well as South America. We can see these fern plants coming all the way around our continents here. Again, all these different species have been found in places that are no longer next to each other because of that continental drift. But we know once were because it would have been impossible for those animals or plants to have survived next, crossing giant oceans. So about 200 million years ago, we see that Pangea broke into two continents here, what we call Laurasia and Gondwanaland, which sounds a little weird, but our northern hemisphere that broke up is part of North America, Europe, and Asia. And then our southern hemisphere, we can see, is South America, Africa, Australia, and Antarctica. So again, seeing these two, the break in Pangea into our two larger, what we would call continents. But again, you can see how our continents are connected and kind of put into puzzle pieces where they, what we would expect them to look like this year now. So again, seeing this cut between the two continents as well. So we can see Laurasia is up here, Gondwanaland is down here. And again, all these different things. We see the Gulf of Mexico, which is a very familiar term nowadays, not in a place that we would expect. But one important thing to note here as well is that when these continents are together, yes, they are still taking up about 1/3 of the Earth, but there's just one giant ocean now. There's no separation really between these oceans because all of the land is found in one place. So again, if we take a look at this separation through time, so we can see in our Permian period, we saw just one large continent. Our Jurassic, we can start to see the division of two. Jurassic, we can see more separation. Cretaceous, more separation here as well. So what we're going to be exploring as we talk about plate tectonics is how these plates are moving apart and what are they doing to show us some of these different things that we wouldn't normally expect from the movement of these plates from that continental drift. If you have any questions, please feel free to reach out.